Alright, welcome back. Video 3.6 here, looking at classifying matter. Now we're going to focus on the mixtures. Main objectives here are to classify mixtures as a homogeneous mixture or a heterogeneous mixture. Make sure you turn off all your distractions, pause, rewind as you need to, and take some notes in your margins and ask those questions later. Here we go. So let's start with a quick review of what we talked about in the previous video. So, matter, all things that have mass and take up space. There's different types of matter. Matter can be a pure substance, which would be like having an element present like oxygen, gold, or iron. Or if you bond elements together, you can have compounds. And you can have a pure substance, which is like salt, NaCl, or sugar, which is C6H12O6, or water, which is H2O. You can have a pure form of those. So if you have just those things, we call those pure substances. And just a quick reminder, elements and compounds can change into each other if you do a chemical reaction to them. You can bond elements together through a reaction to make a compound, and you can split the compound back into its elements through another reaction. Now, if you take two or more of these substances, these pure substances, and mix them together, physically, you make yourself a mixture. So a mixture is just taking pure substances and literally just mixing them together. Whether you stir them together or you dissolve something in each other, that is what we call a mixture. Mixtures, again, are a combination of two or more pure substances. And what's unique about a mixture is that each substance in the mixture, they retain their individual properties. So, for example, if you have salt, which tastes salty, and you have water, which is a liquid, when you mix them together, they kind of retain those properties. Now, salt's not a solid anymore, but it still tastes salty in salt water, and water still has its water properties, being colorless and transparent, that kind of thing. It's also important to know that actually most everything you come in contact with on a daily basis, most things are mixtures, because over time things just tend to mix together and they don't stay separated out very well. So that's also kind of the reason you don't see a lot of the metals on the periodic table. You don't see those things all by themselves in nature. They've kind of been mixed together or chemically bond to other things as well. So back up one more quick second here. Our next step here, now we know what mixtures are, two or more pure substances mixed together. Now we're going to look at a heterogeneous versus a homogeneous mixture. And the heterogeneous mixture, get the prefix hetero there. Hetero means to be different. Okay? If you have a heterogeneous mixture, basically you have a mixture that does not blend evenly. You can see the individual particles. They're distinct from one another. So some really good examples are like Italian salad dressing. This one's been shaken up, and if you let it sit for a while, some stuff will settle out as well. You have freshly squeezed orange juice, which has pulp in it. Here you can see this one's kind of settled out. It's been sitting for so long. And then a solid heterogeneous mixture would be like granite, where you can actually see the individual minerals, the different parts here that make up this type of rock. So a heterogeneous mixture, you can see the different parts because it does not blend evenly. It's different throughout. It looks different throughout. A homogeneous mixture is kind of the opposite there. Homo means to be the same throughout. So a mixture that has a uniform composition throughout or looks the same throughout is called a homogeneous mixture. The individual substances in the mixture are not distinct. You can't see them. And a homogeneous mixture is actually more commonly called a solution. So if we just say solution, we oftentimes mean homogeneous mixture. And if we just say mixture in the future, typically we mean heterogeneous. But there are those prefixes, those words there, heterogeneous versus homogeneous mixture. Some good examples here would be like Kool-Aid. Now, take away the ice there, I guess. But that would be a homogeneous mixture. Kool-Aid is the same all the way throughout there. Air, the air above this water here is a homogeneous mixture. You don't get like a layer of oxygen down here and a lighter nitrogen above it. They mix together all the way through this air here. And these gas particles here, not only are they a mixture up here, they actually go down in the water. I mean, how do fish breathe, do you think? This oxygen can actually dissolve in the water, and it's mixed uniformly through the water as well. And we call that a mixture, a homogeneous mixture. And then a marshmallow is actually a gas mixed in a solid. You can't see the gas bubbles. You can't, or any gas in there. You can't distinguish between the gas and the solid sugar really. So a marshmallow is also considered a mixture, a homogeneous mixture. A special type of homogeneous mixture, and it's got a special name, is called an alloy. Anytime you have a solution that's mostly made of metal with maybe some other metals or nonmetals mixed in, that's called an alloy. And alloys, we manufacture those for their strength and durability. So, for example, iron's a pretty hard metal, but it's not as strong unless you add the carbon there and make it into steel. So steel is a good example of an alloy. We strengthen the iron by adding some carbon into it. And here's an example of steel here. And just so you know, I have a few students who will call these things as elements, but if you look closely, look at the periodic table, you'll never see those words in the periodic table. So they're not elements. They're actually alloys. Brass is a common alloy. It makes up our pennies. It makes up a trumpet here, as you can see. And then bronze, like a bronze metal or other kind of bronze metals out there. Copper and tin are mixed together to make that kind of alloy. And as you can see as well, you can't distinguish the different metals in these things. They look the same all the way through. So they're a homogeneous mixture, and they're a special type. We call them alloys. They're mostly made of metal. Alright, so I want to back up to this chart here one more time just to kind of quickly review it with you. So matter, anything that takes up space and has volume. Most matter is a mixture, and most mixtures can be either classified as heterogeneous or homogeneous. We will throw in a third version of this later this year when we talk more about mixtures, but colloids another one we'll talk about. Mixtures are made of pure substances, and pure substances can occur naturally, and pure substances can be just an element or just a compound, like so. Alright, good job.